There we go. All right, so we are solving linear systems of inequalities by graphing, and I'm just going to explain the process on how that works. First thing is you've got to make boundary lines. So you graph the first boundary line with either a solid or, anybody want to take a guess here? Dotted. Yes, it's either going to be a solid line or a dotted line. Okay? Okay. The next thing, you're going to use, after you get your boundary line put down, you're going to use a test point, an ordered pair, a point that's not on the boundary line, to determine which side of the line to shade lightly. One side of the line has the solutions, the other side does not. Is everybody with me on that? For graphing that? You're going to plug the coordinates of the test point into your inequality. If the resulting statement is true, I had to look ahead a little bit, then shade the side of the line that the test point is on. If it is false, then shade the, do what? Okay, opposite side of your boundary line. Okay? Okay, repeat steps 1 and 2 for each other inequality. I think we're going to focus on just having 2 inequalities in our system. Okay, then you're going to heavily shade the area of the plane that was shaded by all the other inequalities. Okay? So they're going to overlap, and the parts that are shaded that overlap, that's where the solution to the whole system is going to be. All right? Is everybody kind of clear on the steps? Then let's put it into practice here with this example. We're going to sketch the solution of this system of inequalities. So we have 2x plus 3y is greater than or equal to 18. Now, the boundary line, I'll just use BL for boundary line, is 2x plus 3y equals 18. Take the inequality out, put an equal sign in its place. And we did a lot of practicing on this. And this is in standard form. So I like the intercept method when it's in standard form. Is everybody following me from all our practice yesterday? Okay, so I'm going to set up an intercept table. Have a 0 for x, figure out y, have a 0 for y, figure out x. When x is 0, we got 3y equaling 18. And 18 divided by 3 is 6. When y is 0, we got 2x equals 18, and 18 divided by 2 is 9. So I'm going to plot the points 0, 6, 1, 2, 3, 4, 5, 6, and 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And am I going to sketch a solid or a dotted boundary line?
Solid, because it's plus 1.
Right. Because of the or equal to part, this will be a solid line. I'm going to put a couple of points. If you go down 2 over 3, a couple places, you can kind of follow along. All right. And getting it in the right place is kind of important. We aren't putting a straight edge down, but I am going to make a solid line here. Okay. So there's my boundary line, and it is a solid boundary line. And have made one of these just less than or something. Okay, now, test point. TP in this context stands for test point, not something else. But I always, if I can, pick a point that's not on the line and that's the origin is not on the line. I like to pick 0, 0 as my test point when I can. Okay, plug it into the inequality. 2 times 0 plus 3 times 0 is greater than or equal to 18. That's 0 plus 0 is greater than or equal to 18. Tell me, true or false? False. 0 is not greater than or equal to 18. That means the points on this side of the boundary line don't work. The points on this side of the boundary line do work. You with me there? All right, so I'm lightly shading this side of the boundary line. Any questions yet? Here. We good? All right, we repeat this process for the second one. All right, my boundary line is y equals 2x minus 3 for the second one. Put a divider there. Okay, now that one's in slope-intercept form. I'm going to change colors on this too. Not that, I'm not even sure you can tell the difference, but now the slope is 2 and the y-intercept is negative 3. So let's begin on that y-intercept negative 3 and then do a rise over run. Up 2 over 1, up 2 over 1. Do that several times. And go down to left 1, down to left 1. Okay. And let me check something here real quick. I don't know if my mic is on. Zoomers. Okay, is my mic on, guys? Okay. Is this the first? Give me a thumbs up if this is the first you've heard me in the lesson today.
We're going to finish the next and then do the worksheet.
Can you hear me? Okay, thank you. All right. Now, if you are, I will have this posted. Try one more time here. I will have this posted. If you didn't hear the first part. All right. Now, okay, sorry about that. So, are we drawing a solid line or dotted line? Okay, this one would be solid also. If the line weren't under here, if it was just y is less than 2x minus 3, then that would mean dotted. Okay. Okay. So draw your solid line. Okay, and I can use 0, 0 for a test point again because it's not on the boundary line. If it's on the boundary line, you can't use it. It won't do you any good. So let's go 0, 0 here, and put 0 in for y. See if that's less than or equal to 2 times 0 minus 3. Is 0 less than or equal to negative 3? True or false there?
False.
That is false. Okay, that's false. This side of the line is false. That means this side of the line is true. So I'm going to lightly shade this side of the line. And I've got all the inequalities plotted. We're going to make our final answer. We've got step 3 done here. We've repeated the steps 1 and 2. Heavily shade the area of the plane that was shaded by all of the inequalities. I got 1, 2, 3, 4 sections here. Which one do you think is the one we need to shade, Abby? Upper right? Yes. Okay. This is the part that got hit. It's on this side of this line and this side of this line. So let's color that part in. Okay, what do you think? Any questions? So the ordered pairs, like this one right here, that is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. The ordered pairs 7, 6, and all other ordered pairs would be true in this one and in this one. Some of them will be true in one but not the other. Some of them will not be true in either one. This is the solution for the system mode. Is everybody with me? Ordered pairs and that. Okay. I'm going to stop the video.